This lesson will deal with value returning functions. In the previous lesson, you learned how to create and invoke void functions, which are functions that do not return a value. Creating and invoking a value returning function is very similar to creating and invoking a void function. You typically enter the same three items of information, that is, a function prototype, one or more function calls, and a function definition. The syntax for creating and declaring a value returning function differs from the syntax for creating and declaring a void function in two basic ways. First, a value returning function syntax begins with a return data type, which indicates the type of data the function will return. You will recall that a void function syntax begins with the keyword void, which indicates the function will not return a value. Secondly, the last statement in a value returning function is always return and then an expression, where the expression represents the only value the function will return. A void function does not return a value. Demo 8 will serve as an example for value returning functions. You will note that under the function prototypes, I now have three functions declared. The void is the display line, which was used in the previous example. The two value returning functions are calc_square and calc_half. This program will behave in the same manner as the previous demonstration. It's just that now this is using value returning functions to do the calculations as opposed to being done in the main function itself. So we have the function prototypes defined. Note that the keyword float is in parentheses to indicate the type of parameter being passed. You'll also note, and this is what makes this a value returning function, is that the keyword float precedes each function prototype. This indicates that the result of this function will return a float data type. Scrolling down to the calling statement, or statements, you'll note that there are two statements that are being used to call these functions. The result of these functions have to have some place to be stored, and they're being stored in number squared and number halved, respectively. The calling statement is actually embedded in the expression. Calc_square is the name of the function. Number input is being passed to this function. Number input, you'll recall, is the number which the user inputs. And likewise, calc_half is passing to its function also the value of number input. Scrolling to the function definitions, you will note that we now have function headers for both calc_square and calc_half. Inside of each of these functions, we have a local variable, that is num_sq, which is the local variable version of the num squared. And the calculation takes place here, where we're simply multiplying number input times itself. You'll note that the return statement is returning the value of num square. This num_sq is a local variable, but since it's associated with the return statement, it gets returned to the calling statement, and in turn gets returned back to the value of number squared, which then gets displayed as the result. The same thing takes place with the calc_half, where we have a local variable called num_half. The calculation takes place, which is the number input divided by 2, and then the return statement returns the value to the calling statement, which in this case is here. And then the result of that calculation gets stored in number halved, which then in turn gets displayed in the cout statements below. Let's compile this program to observe the execution. If I type in 9, you'll notice that the calculations still behave as you might expect. The square of the number and the half of the number has been calculated. Once again, from the user's perspective, there's really no difference between this version and the version used previously in Demo 7. Demo 8 is a program you might want to study in more length.